Hey, welcome back to our notes. We are at section 7.2 today. So 7.2 in our books, this is going to be dealing with properties of parallelograms. So let's go to page 202. And at the top, we have a vocab word, parallelogram. What a parallelogram is, it's where you have a quadrilateral, okay, where both pairs of opposite sides are parallel. That'll be our vocab. So quadrilateral, where both pairs of opposite sides are parallel. Okay. So I'm going to read through these four theorems. So theorem 7.3 is called the parallelogram opposite sides theorem. I'm just going to read it and then we'll apply it later. It says if a quadrilateral is a parallelogram, then the opposite sides are congruent. So we can see that here. Parallel opposite angles theorem says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So that means if you look at these two together, that means if we have a parallelogram, we know opposite sides are congruent and then opposite angles are congruent. Then we go to the next theorem. Theorem 7.5 says that if a quadrilateral is a parallelogram, then their consecutive angles are supplementary, which means they add to 180. So if I look here, I can look at consecutive would be angle X and angle Y. These two added together are going to be 180. Or I can do this side here, angle X and angle Y add together equals 180. So that is going to deal with all parallelograms. So now that we know that opposite sides are the same, opposite angles are the same, and consecutive angles are supplementary, the one that's a little bit new is the parallelogram diagonals theorem. I'm going to read this verbatim here. If a quadrilateral is a parallelogram, so when we have a parallelogram, it says then its diagonals bisect each other. So if I look at this parallelogram over here and I make a diagonal, so go from one vertex to the one opposite, and then same thing, and they meet here in the middle, when these diagonals meet at point M, it now bisects each other. Remember, bisects means it makes two congruent segments. Okay, so their diagonals bisect each other, making congruent parts. All right, so with all that being said, let's go ahead and do some examples of using this stuff. Man, we're flying through this. This is great. So next page, extra practice. Find the value of x of each variable in the parallelogram. So let's look at question number one. Maybe I'll zoom in a little bit bigger here. There we go. So number one, what we have is it says we have a parallelogram. So what we know is we have the two sides are opposite each other, are the same. So I see 4x and y. Now the problem is if I mark this being a parallelogram, I know these two sides are congruent and these two sides are now congruent. I don't want to do anything about the top and the bottom here because they're different variables. What I see are the left and right sides because we don't want to have to worry about a system of equations. So we have here is I can solve for x by saying I know that x plus 18 is going to be congruent or the same as 3x minus 2. So I'm going to go ahead and solve this. I'm going to jump ahead and I'm going to get x equals 10. So I found what x is worth. So it says find the value of each variable. There's 10. Well, if I plug that 10 back in here for this x, I'm going to get 4 times 10, which is 40. It just so happens that's congruent with y, so now we know that y equals 40. So here's our two answers, 10 and 40. Not too bad, not too bad. So let's do the same thing here for number two. Now we know opposite sides are the same and opposite angles. Again, I don't want to mess with the sides right here because I have two different variables. But notice my opposite angles. My opposite angles, there's only one variable, and we know that opposite angles are congruent. So I can set 4x minus 37 equals to 49. And when I solve this, I'm going to get the x equals 21.5. So now I'm going to take that 21.5, there's my first answer, and I need to take that 21.5 and plug it back in here for that 4x minus 3. So 4 times 21.5 minus 3, that gives me 83. Helps if I can write an 8. There we go, 83. Now, how is this helpful? I know these two sides are congruent. So I can write down that y over 5 equals 83. So let's go ahead and take 83 and multiply that by 5. And I get that y equals 415. All right, let's keep going. Let's go to question number 3. So we have some diagonals here, and I know they're diagonals because they are going from one vertex to the other. That one's opposite. So here's what we do know is that the 5y minus 16 is congruent to the 3y. So I can write that down. I know 5y minus 16 is the same thing as 3y. And I also know that these other two are going to be congruent. So that's going to be my 2x plus 10 is the same as 4x minus 2. So I have these set up. Let's go ahead and solve these. When you solve for the y, I'm going to get that y equals 8. Again, I'm not showing those algebra steps. I'll leave that for you. And then for the x, solve that multi-step equation, and I get x equals 6. So notice we've used all those theorems so far. We've used opposite sides are congruent, opposite angles are congruent, and diagonals bisect each other. Okay. So we've done all of those theorems. If I go back and quickly look, the only thing we haven't done is that consecutive angles are supplementary. It's the only theorem we have not seen yet in these examples. So let's keep going. Let's go to this next section. So I'm going to make this right here. It's going to be a little small at times. So we have one big diagram here, and the thing here is it says indicate, find the measure in, indicate a measure in, and this is a parallelogram symbol. So the parallelogram, MNOP. So this is given that we have a parallelogram, but it says explain our reasoning. So this is where we want to mention our theorems. That's our explain. When it says explain, I want you to say which theorem. All right, PO. Now we have all this stuff done, and actually maybe before we do that, we can fill in stuff that we know. Because it's a parallelogram, I know if MO is 14, that QO is also 14. If I know that NQ is 20.7, PQ is 20.7, I know if one side's 26, the other side's 26, and if the top's 24, the bottom's 24. Notice this picture up here. This is showing that this is an angle bisector. So if we wanted to, we could, sorry, now it doesn't show that's an angle bisector. This is showing that the whole angle is 68 degrees. Sorry, I can't believe I messed that up. The whole angle is 68 degrees, which means my opposite angle, which is angle P down here, this is going to be congruent. This is also 68 degrees. And look at what we have on the bottom right of this diagram. The bottom right of this diagram says 59. Now, what we do know is these two, angle P, big angle P, and big angle O are supplementary. So really quick, I know that I'm going to have to take 180 minus 68, and that'll give me the big angle O, but I know part of it's 59. So if I subtract that 59, what's going to give me is this one little itty bitty missing piece here also. So if you put that in the calculator, you get 53 degrees. So this is 53 degrees. And also 59 plus 53 means the whole thing, this whole thing right here is 112 degrees. So this whole thing is 112 degrees. I pretty much have every single thing figured out. So now we can go through and write down all of our answers, but then we can go back and say, how did we fill that diagram out? What theorem allowed us to do that? I didn't mention those theorems as we were putting these out. So PO, if I look back at the diagram, that is 24. Now, how do we know that's 24? That was our opposite sides theorem. Now I might stop writing theorem. I might just put opposite sides. If we look at number 5, it asks for OQ. OQ dealt with the diagonal theorem, and we wrote down that that was 14. So this is our diagonal theorem. Diagonal theorem. Actually, I'll just abbreviate. Maybe not even the correct way to abbreviate theorem. Maybe it should be an M. I don't know. Anyways, diagonal theorem. And then number 6, NO. We know it was 26 in our diagram. We got that again because of the opposite sides. And then number 7, we had that was 20.7. Again, that was the diagonals theorem. The diagonals theorem. And then how do we get P, angle PMN? Well, what happened is we used our consecutive angles theorem, and we knew that that was 102 degrees. Is that what I wrote there? Oh, I wrote 112. Let me just double check that that is 112. I'm going to pause this for a second. All right, I just paused it because I was looking at one that I had filled out before. And yes, we were right with that 112. So I'm going to write down this was 112 degrees, and we figured out because of our consecutive angles theorem. Consecutive angles. Now remember, it's our consecutive angles theorem deals with our parallelogram. So all of these theorems were parallelogram consecutive angles, parallelogram diagonals, parallelogram opposite angles, parallelogram opposite sides. So that'd be like the official name we'd have here. Sorry, excuse me. Measurement of angle NOP. That's where we had to take that 112 that we had, and you could subtract that 59, and we found that was 53 degrees. So this was 53 degrees. Now we did a couple things here. We did this by the opposite angles theorem. Okay, that's how I figured this out. And also, you could say opposite angles combined with consecutive angles. So it's a little bit of a mixture there. So it depends on which one you're saying. But I'm just going to say opposite angles here. Measurement of angle OPM. So if I look at O to P to M, that's that bottom big angle P. That was the opposite angles theorem. We had 68 degrees. So opposite angles theorem again. And then measurement of NMO. N to M to O. Now, what would we have here? This was going to be also 59 degrees. Now, how do we know that? Sorry. If I look back, remember, this is a parallelogram. So I could go back in and write down these are parallel lines. If we have parallel lines, what happens is this line right here is a transversal. Because what happens is our line extends. So what's happened is I have two parallel lines and a line that extends. And if I look at, sorry, I drew that transversal the wrong way. Here we go. I am looking at this angle I'm going to put right here. I'm going to shade in blue. And it wants us to find measure of NMO, which is right up here. I don't know if you can see that. I drew it really small. But if you look with our parallel lines, our transversal, these are opposite, sorry, not opposite, I'm going to say alternate interior angles. So this is our alternate interior angles theorem back from earlier this year. All right, that's our notes. Yeah, so best of luck on the assignment, and we'll see you in class or the next video. Have a great day.